is being.
Okay, guys, so we're going to start on chapter 2 today. Chapter 2 is basically dealing with frequency tables, relative frequency tables, and histograms. And it's a pretty nice section, just involves a lot of tables. So it's just something we're going to get used to. Okay, so, and remember the numbering in the notes is sometimes a little bit off from the numbering in the homework. So this says 2.1, but in reality, 2.1 in your homework probably starts right there at 2.2. Okay, so don't let that freak you out. It should be okay. So in this chapter, our objective is to understand our data by collecting raw data, organizing data in frequency distributions, and presenting data in graphs. So characteristics of data, center of data is a representative value that indicates where the middle of the data set is located. That's something we deal with a lot in statistics. We really like to know the center of data. Variation spread, a measure of the amount that the data values vary among themselves, how spread out the data values are from one another. Distribution, the nature or shape of the data, such as bell-shaped, symmetric, uniform, or skewed. Outliers, data values that lie very far away from the vast majority of the other data values, and time, changing characteristics of data over time. Okay, so again, the big deal for us is center. Variation matters a lot in terms of standard deviation. And then we discuss the distribution, and sometimes the outliers come into play. So for us, frequency distribution shows how a data set or a frequency table shows how a data set is partitioned among all several categories or classes of numbers by listing all categories or classes along the number frequency of data values in each of them. The frequency for a particular category or class is the number or count of individuals that fall into the class or category. So basically, frequency is a fancy way of saying how often something occurs. The frequency of this, the number of times this occurs. Okay, so for us, it says, this example one says, a physical therapist wants to get a sense of the type of rehabilitation required by her patient. In order to do this, she obtains a simple random sample of 30 of her patient records and records the body parts requiring rehabilitation. See table 1 below. So, you know, and you guys can imagine if you were a small practice and you weren't part of some big corporation, you'd probably have to do a lot of stuff like this for yourself. So this person decided to take a simple random sample of her patients, and doing that, she found that 12 had back pain, 2 wrist, 1 elbow, 2 hip, 4 shoulder, so on and so on and so on. And she had a total of 30 people in her little simple random sample. Now the thing is that she did it correctly. She did a simple random sample, and who knows why she's doing this. She might be doing this because she has a certain amount of money she wants to invest in new equipment. So she wants to make sure that the new money or the money she invests in new equipment is for something that she actually uses a lot. So if she focused on something around back pain, some kind of tools or new technology for back pain, that would probably serve her well, because that seems to be what most people come to her for in her study. So what type of variable is body part? Well, we know that that is categorical. Okay, and it says an important variation of basic frequency distribution is relative frequency distribution. So if this is just the distribution of, 30 people, how many had back, how many had wrist, how many had elbows, so on and so on and so on. And then we wanted to find out what percentage or what proportion or what ratio of her clients, I guess you could say, or her patients had these body parts with this pain. We would use a relative frequency distribution, and all relative frequency is the frequency of that particular, in this case, that particular body part divided by the total of 30. So we come over here and we see, here's a relative frequency distribution for the above. So all she did was she took, 12, right? Because there were 12 people with back pain. She took 12 and divided it by 30, right? And if you take out your calculator and you do 12 divided by 30, you'll get 0.4. which is equal to 40%. So make sure when you're doing the homework, if they ask for the percentage, you give them 40%. If they just ask for the number, you give them 0.4. Okay, so it really depends on what they ask for. And you could do the same for each one of these. Let's see, wrist was 2. So if we do 2 divided by 30, so 2 divided by 30, we would get 0.067. It's actually 0.666666 bar, right? But that's about 6.7, oops. Because they wanted you to round off to a certain number of variables in this. It looks like two decimals for the percentage. Okay, and you could go on and on and on. So how did she calculate her relative frequency? So again, we just talked about it. So she just did the frequency of a particular category and divided it by 30, right? And we already did one. 12 divided by 30 would equal 0.4, which is 40%, okay? What is one conclusion we could draw from the relative frequency table? Well, it looks like 40% of the people that see her in her study have back pain. So now again, she'd have to go on to do a hypothesis test, and there's a bunch of other stuff we could do statistically. But just based on this data, it seems like most people that see her, or around 40% of her patients, experience back pain. So most people, or let's say a large portion of her patients have back pain, right? No big deal. And that's pretty obvious from that. Now, what if you wanted to say, oh, well, we're going to buy some new equipment, and anybody that has wrist or elbow or shoulder or hand would all benefit from this technology. Then you could add all those up. And that could be something like a cumulative frequency, where you could say, well, this, and this. But it really depends on the setup of the problem if you would be able to do it perfectly like that, okay? So another variation of frequency distribution is cumulative frequency distribution. A cumulative frequency includes that frequency and the sum of all the frequencies that came before it. A cumulative relative frequency is a cumulative frequency divided by the total. So these are very similar, except cumulative adds up all the values before that particular category. So if we're here in category 9, it says systolic blood pressure, they have it between 80 and 99. They have 100 and 119. They have 120, 139, so on and so on and so on. And then this is the frequency. So just this right here, if we built this table, this would be what we call a frequency table, and we'd be done. But now they want us to add and call it a relative frequency table. So all we have to do is we have to find out how many are there. So let's see here. It appears that there are 40, right? If we add all these up, there are 40. Okay, so let me see here. 10, 24 plus 10 is 34, plus 5 is 39, plus 1 is 40. So there's a total of 40. So I'm going to do 9 divided by 40, and let's see what that gives us. That's going to give us 0.225. Now, if they want the percentage, I would give them 22.5%. Okay, so let's do that for all of these. Okay, so the relative frequency for 24, if I do 24 divided by 40, I should get 0.60, which is about 60%. Let's do 5. 5 is out of 40 is 1/8, so that's 0.125, and that equals about 12.5%. This is kind of, let me fix this. It's not writing small enough. Let me see if I can change this a little bit. Okay, so let's say we have 9 divided by 40. We know that's 22.5%. You know what? I'll do 0.225 first. 0.225. We have which is 22.5%. We have 24, which is 0.60, which is 60%. We have 0.5, which is 0.125, which is 12.5%. We have 1, that would be 0.025, which is approximately 2.5%, not approximately, it is. And then this would be 0, so this would be 0%. And then once again, 0.025 equals 2.5%. So now we have, now if we just stopped here, this would be our relative frequency table. So we have our categories, we have our frequency, and we have our relative frequency. So this would be a relative frequency table, okay? But now they want more. So they want a cumulative frequency table. And again, this is kind of a catch-all. It's having us do everything. You know, on the homework, they may only ask you for a relative frequency. They may only ask you for cumulative frequency. But I'm just kind of in this problem showing you everything, what all of it could be tied together. So cumulative frequency says, well, the first one is 9, but then it says the next one in the cumulative frequency would be 9 plus 24, which would be 33. And then the next one would be 9 plus 24 plus 5, which would be 38, plus 1, which would be 39, plus 0 would be 39, and plus 1 would be 40. And you'll always, in a cumulative frequency table, you'll always end with the total, right? Because you're taking everybody into account with the cumulative. You add all the rows that came before it, so, or all the frequencies that come before the one that you're on. So basically you're saying, for example, if I were here, I would be saying, you know, 120 to 139 or below. How many people have below 139? Well, we would say 38 because that's 9 plus 33 plus the 5, right? 9 plus 24, 9 plus 24 plus 5 would be 38. Okay, so that's what we were doing here, all right? So now the cumulative relative frequency is now you have to take all of these numbers and divide it by 40. So 9 divided by 40, we already know is 22.5%. I'm just going to write the percent for this one. Just to make it easier, 22.5%. 33 would be 82.5%. 38 would be 95%. 39 would be 97.5%. This is still 97.5%. And then the last one will be 100%. And remember, with a cumulative relative frequency, by the last category, you should always end with 100 because you've now accounted for everything. Okay. So something else we talk about is lower class limits and upper class limits. So the lower class limit, okay, the lower class limit is the smallest number that can belong to the different classes. So in this case, our lower class limit is 80, 100, 120, 140, 160, and 180, right? So let's write those. So it's going to be 80, 100, 120, 140, 160, 180. So those would be our lower class limits. Now our upper class limits of each category is 99, 119, 139, 159, 179, 199, okay? So then it says class boundaries, the numbers used to separate the classes but without the gaps created by the class limits. Split the difference between the end of one class and the beginning of the next class. Okay, so in this particular case, we have to basically, what's between 99 and 100? Well, that would be 99.5. What's between 119 and 120? That'd be 119.5. So what I'm going to do is I'm going to start with the smallest one, which would be 79.5, right? 99.5, 119.5, 139.5, oops, and 159.5. And I think 179.5. Yep. And all I'm doing is I'm taking 179 and 180, I add them and then divide by 2, right? So I split the difference and it'll be 179.5. And I do that for each one. I take the lower class, the upper class limit, and then the next category's lower class limit, I add them and divide by 2, and these are the numbers I would get. But you don't actually have to do the math for it. You could kind of see what's between, 139 and 140 would be 139.5. Class midpoints are the values that are in the middle of the classes. Okay, so the value in the middle of the classes. So if I go from 80 to 99 and I take these two values, I do 80 plus 99 on my calculator. And then I divide by 2, I find smack dab in the middle would be 89.5. Then the next one, the next category, 100 and 119, 100 plus 119, divide that by 2, find out what's smack dab in the middle, that'd be 109.5. And then I just go on from there, 129.5, 149.5, 169.5, 189.5. Okay, and those would be my midpoints, my class midpoints. Now it's pretty easy to find the class widths, the difference between two consecutive lower class limits or two consecutive class boundaries. Okay, so if we look, how far is it from 79.5 to 99.5? It's 20, right? That's one way we could check. Or we could come over here and we could say lower class limit to the next lower class limit. How far is that? That's 20. What about from this lower class limit to this lower class limit? That's 20. We could also do it with upper class limits. How much from that upper class limit to that upper class limit? 20. So the class width is 20, but if you don't pay attention, you might accidentally say, oh, it's 19. It's not, it's actually 20 because they're counting the 80 as one of the numbers. Okay, so, sorry about that, you guys. Somebody's doing construction in my neighborhood. I don't know if you guys can hear the saw in the background, but I tried to close a window right now. Okay, so our class width is 20. We're good on that. Let's continue on. Okay, so something we're going to spend a lot of time starting in chapter 6. We will cover a little bit of it now, but just as kind of a heads up, normal distribution is kind of like our favorite in statistics. Frequencies start low, then they increase to some point where the maximum frequency is achieved, then they decrease to a low like a mountain or with one peak. So a lot of times what we look at for this is you would have something that goes like this and then like that. That's a lot of times what we visualize as normal distribution. The distribution should be approximately symmetric with frequencies evenly distributed on both sides of the maximum frequency. So it should have like this bell shape. Okay, so we're going to spend a lot of time on this in chapter 6, 7, 8, 9, and 10. But for now, I just wanted to kind of have it in the notes and just mention that it's there. And we'll talk a little bit more about it later on. Even in chapter, I believe, maybe the end of chapter 2 or chapter 3, we'll talk about it a little more as well when we get into z-scores. But again, that'll just be kind of like a preview of it. That's not really in depth what we're going to do. Okay, so now we can move on to histograms. A histogram is a graph consisting of bars of equal width drawn adjacent to each other, unless there are gaps in the data. I've even seen sometimes the computer will draw it with gaps in between, not intending it to be gaps in data. I don't know why they do that sometimes, because by the very definition, it's not supposed to have gaps in the data unless there's actually missing data for those particular values. So it says the horizontal scale, or the x-axis, represents classes of quantitative data values, and vertical scale represents frequencies. So we have the x-axis represents classes, and the y-axis, or the vertical scale, represents frequencies. So the y-axis or vertical scale will represent how many, how often, right? And the x-axis will be the categories. So each class represents a interval or range, okay? The bars in a histogram are touching or adjacent, and their height represents the frequency for that class. Histograms are good for large data sets, and the class and counts in each class give the distribution of the quantitative area. A lot of times, you know, if you're given a big bulk of data, a histogram is a really good way to enter in that data. It can handle large quantities of data very well. So just keep that in mind. Other things that we're going to work on in chapter 2 don't handle large values of data as well, just because they're a little bit more cumbersome to work with. A relative frequency histogram will have the same shape and horizontal scale as the histogram, but instead the vertical scale will be marked with relative frequency or percentages or proportions. So in this case, it'll be, you know, from 0 to 1, or, you know, it'll go by 0.1, 0.2, 0.3. Instead of the actual frequencies, it'll be the proportions or the percentages. Okay. So that's not too big of a deal. So it says group frequency distribution of psychology test scores. Below are the scores of 642 students on a psychology test. The test consists of 197 items, each graded as correct or incorrect. The student scores ranged from 40 to 167. And so you see that they have the interval from 40 to 50, 49, so on and so on and so on, okay? So let's scroll down, and they want us to use that data to build our histogram. Okay, so it says draw the histogram. So they already have number of students here, which is our frequency, and here they have our categories, right? So we need to kind of think of a few things, okay? What would you guys say the class width would be? Right, the class width should be 10, because from 40 to 50 would be 10, all right? So we can technically start our graph. Oh, they already started it for us at 40, okay? So what I'm gonna do is I'm gonna draw my histogram, and I'm gonna do the best I can, right? Because if we look here, how many people were from 40 to 49? So there were only 3. So that's gonna be really hard to draw. So what I'm gonna do is I'm gonna just kind of do this little short histogram right here. Okay, so that's, it's really hard to draw. Maybe I can make it like this. So let's say like 3 is like right there. Okay, and then 50 to 59 had 10. So that would be about 1/3 of the way up. That's about halfway. So from 50 to 59, okay, so it's supposed to be straight lines, but you guys get the idea. Now from 60 to 69, we got 53. So that's gonna be way up here. I'm gonna put that right about here. And again, these are supposed to be straight across. I just can't draw straight lines with this. Well, ever, really. Okay, so then the next one, let's look at. So the next one should be 70 to 79. That would be 107. So that's going to be, if this is 90, here's 100, here's 110, here's 120. So 100, 110, so it would be right about here, you say? And then across, and then down to 90. And then 80 to 89, we got 147. So that's going to be almost to 150. I'm just going to kind of estimate it to be almost to 150. And then 100 to 109 is 78. Oops, wait, I need 90 to 99. That's 130. So let's call it right about here. And then 100 to 109, that's 78. So that's almost 80. Let's call that right about here. And again, I'm doing the best I can. It's not perfect, right? But it's supposed to, oops, what am I doing? 78, I said. Oh my gosh. Let's go right there. And then 110 to 119 would be 60, about 59. So I'm going to make it really darn close to 60. And then 120 to 129 would be 36. So it's just a little above 30. So right about there. Right. And then 130 to 139 would be 11. I think you guys are getting the idea. right about like that. 140 to 149 is 6, so it's going to be really hard to draw now. And then 150 to 159 would be 1, so I'm just going to draw like a green line, and then 160 is 1 again, so I'm just going to draw like a green line right there. So that is my histogram. Now, if I drew like a little curve, my curve would go kind of like this, right? If I kind of connected everything. Okay, so that curve would be called right skewed because the tail on the right looks a little bit longer. Okay, that's how I recognize it. The skewness of a graph in general is basically where there's a longer tail, because that means there's more categories on the right side or on the left side. So in this case, there's more categories covered, so we'd call this right skewed. Okay. So we do class boundaries. We would know how to find that. Class midpoints, lower class limits. It really depends on how you want to set it up. For ours, we use lower class limits. You could also use class midpoints. A lot of graphs I've seen use class midpoints as ways to draw your histogram. Okay, so that's a good start for that one. It says the relative frequency histogram would look exactly the same. The only change would be the vertical axis would be relative frequency rather than frequency. So instead of being 0, 30, 150, it would be percentages or decimal points, right? Adding up to 1. Okay. Interpreting histogram. Is the histogram uniform, bell-shaped, skewed? Are there any unusual data values, outliers? So outliers is kind of a gray area that we won't really get heavily into until the end of chapter 3. And we'll use a method with the IQR, the interquartile range, to identify outliers. So for now, kind of when we think of outliers, we kind of just have to recognize it seems like it's very far away from the rest of the data, okay? Uniform distribution, I think you guys can all kind of see that it's distribution. It doesn't have to be exactly the same, but you see how a lot of the values are similar. So for uniform distribution, it'll be something like this. It won't have these shapes like that. And these aren't the only shapes. You guys know there could be data like this. But for our class, we're really looking for this type of one peak in general. I'm not saying that's the way it always works, but for our class, that seems to be a lot of what we work with. Oops. Did I move anything on accident? No, I'm okay. All right. So now we'll talk a little bit about normal distribution. The left and the right side of the histograms are approximately mirror images of each other, and there is a bell shape where the peak occurs in the middle. So again, this looks like symmetric distribution, right? Basically, it's not exact, but it looks pretty good. This is approximately normal distribution, right? Again, not perfect, but it doesn't really look skewed one way or the other. Now we come over here, this one, if we draw this, right? It looks like the tail on the right is a little bit longer, so we say that it's right skewed. If we draw this, it looks like the tail on the left is a little bit longer, so we say left skewed. Okay, hopefully that makes sense to everybody. Okay, spaces separating data are called gaps. So for right here, for example, there is no data for 40, so percentage of adults with bachelor's degrees. So for them at 40, there is a missing data from there. There's an actual gap, so that's why it's not drawn adjacent to one another. And then outliers, data values are set far apart from the rest of the body of the distribution. So again, we haven't talked about an actual way to find if something is an outlier or not, but for now, it looks like that one is pretty much off to the side of the rest of the data. It's far apart, so we're gonna say it's an outlier. But again, we're gonna develop throughout the class a little bit better way to talk about outliers and deal with them. Something really important from chapter 2 is center of data. Or actually, to be honest with you, for the remainder of the course is the center of data. So the center of distribution is usually described by the midpoint or median. Also, we'll talk about the mean as well, which is the value that has half of the observations taking smaller values and half of the observation taking larger values. To find the midpoint location of your data, you can use the location formula. So this formula is just a nice basic n+1, n being how many values are in your table. And you add 1 to it and then divide by 2. So it says, use the histogram to count to the interval containing the midpoint by counting the frequency in each until you get the location of the median. The interval that contains the location of the median is the center, the median interval. So that's a really wordy way of saying this, but this is something that we have to think about. So I really think an example, like we see in this next one, will make more sense. So it says the following histogram represents the number of years for which 24 workers have been with their current employers. So again, this is kind of counting on, do you know how to read a histogram? So these are the categories, right? 2 to 4, 5 to 7, 8 to 11, or 8 to 10, so on and so on and so on. Okay. And the reason I'm not saying 5, 8, 11, 14, 17, and 20 is you have to be a little bit careful with that. Because if you say, let's say that you told me that the categories were from 2 to 5, there were from 5 to 8, there were from 8 to 11, there were from 11 to 14, 14 to 17. Do you guys see the problem? What about the number 17? What if I said 17, right? Oops, I just made that worse. Well, 17 would go into this category, but wouldn't 17 also go into this category? So you can't have numbers overlapping. So what we have to do instead is we have to say that our categories are from 2 to 4. Again, they didn't give us a perfect background on this, but this is what I feel. These are our intervals, 2 to 4, 5 to 7, 8 to 10, 11 to 13, 14 to 16, 17 to 19, and let's see here, 17 to 19. Oh, they don't have anything after 20, so we're okay on that. So that would be our intervals, right? This is our intervals. And remember, this came from so this histogram came from a frequency distribution, right? So they're telling us these are the categories. This is our categorical values, number of years they were with their company. And then this is how many times or how many people were in each of those categories when we gathered data. How often did we get data values from 2 to 4, 5 to 7, 8 to 10, 11, so on and so on and so on. So if we had to draw a skewness to this, okay, so it appears there's a little bit more of a tail on the left side than the right side. So we're going to say that this is left skewed. Normally it's pretty obvious. This one's a little bit closer, but normally it's pretty obvious. Find the class interval that contains the midpoint. So this is what I wanted to talk to you guys about, because the class interval that contains the midpoint is not necessarily this one right here, because you'd say, oh, that looks like the center of the data. Right? So what we have to do is we kind of go over here and it says, use the histogram to count to the interval containing the midpoint. So the first way that we do this is we have to, so let me see here. It says the midpoint or the median, and it says location of the median is n+1 divided by 2. So in this case, how many people were there in this study? Well, there were 24 people in this study. It says right here, 24 workers, 24 individuals. So we're going to do 24 plus 1 divided by 2, which would be 12.5. Oops. Yeah, 12.5. Okay. So now we're going to count until we get to about 12.5. So I'm going to count. Okay. So how many people are here? 2. Right? Oops, that's not very visible. Let me see if this is better. 2. How many people are here? 1. So far, that's 3 people. How many people are here? That's 4. So far, that's 7 people. How many people are here? This is 9, right? I'm just using the histogram. And I got to get to 12.5. So this is 2, 3, 7, 16, right? So did we definitely make it to 12.5 in here somewhere? So in this case, it does appear that it's the midpoint, but it doesn't always work where that's the exact middle value. So we're going to say our interval, our median interval, is from 11 to 13 years. I guess I don't know why I started using commas halfway through. Sorry about that, you guys. 8 to 10 years, 11 to 13, 14 to 16, and 17 to 19. Too used to interval notation with algebra. So do you guys see how I did that? I counted. Here's 2 plus 1 is 3, plus 4 is 7, plus 9 is 16. So somewhere in between here and here, I got to 12.5. Well, I can't say that this has the median in it because we've only accounted for 7 people at this point. So somewhere in this histogram, somewhere in here, we passed the 12.5 person, okay? So the 12 or 13th person. And that happens somewhere in the interval from 11 to 13. So that is our median interval. And it's not because the number 12.5 is in here, like 12.5 years, it's because the frequency, the 12.5 person was in there, okay? So let's talk about spread. How many pages do I have left? Hold on real quick. We can go a little bit longer in this first video. Okay, so let's talk about spread. The range from the beginning interval to the highest value interval. Often we mention the spread as the range of the smallest to largest value without outliers and mention our outliers separately. So you normally have to let somebody know that you're dealing with an outlier, okay? So it says a histogram showing the number of tornadoes in the United States in 2000 for each of the 50 states. So it shows number of states. So it says from 0 to 19 tornadoes. How many states had 0 to 19 tornadoes? So again, we don't know if it was 1 tornado, 0 tornadoes, 2. We just know 0 to 19 was the category they chose to separate tornadoes by. So 0 to 19, 20 to 39, not how fast the tornadoes were going, how many of the tornadoes. And then it said how many states had that many tornadoes. So in this case, from 0 to 19, there were 30 states that had 0 to 19 tornadoes. Then if we go and look at this next one, there were from 20 to 39 tornadoes, there were only 10 states that had that. So it says, how can we describe the spread of the distribution? Okay, so let's talk about the spread first of all. We know the smallest interval, so smallest to largest is going to be 0 to 19. And then the largest will be 60 to 79, okay? Now, why am I not talking about this one? Is because I feel that this is an outlier, okay? So we're gonna say with an outlier of the category 140 to 159, okay? And what would our midpoint be if we wanted? Well, we know there were 50 states, so we're going to take what category would have the midpoint. So 51 divided by 2 would be 25.5. So if we wanted to find the, what do they call it up here? The interval midpoint, median interval. So we're going to find the median interval. If we wanted to find that, we would have to find where the 25.5 takes place, the 25.5 states take place. Well, as it turns out, how many are right here in this first category? This first category of 0 to 19 has 30 states. So the median interval is actually 0 to 19, the very first one. See how that does not look like the center of the data, but you have to understand that a large portion of the data is from 0 to 19 tornadoes. So most states do not have a lot of tornadoes. 19 is the most in this category. Okay, so the median interval 25.5 happens somewhere in here, right? The 25, if I lined up all 50 states, starting from the smallest amount of tornadoes to the largest amount of tornadoes, and I got to the 25th state, right? The 25th and 26th states, how many tornadoes would they have? Well, they would have somewhere between 0 and 19, because remember, this is lined up in order, okay? So that's one way to think about it. Okay, oops. Okay, so it says a meteorological station in Hawaii has gathered the following average daily wind speeds over 43 days. In the following histogram, these average speeds on miles per hour are displayed. So they gathered wind speeds over 43 days. And again, this is a good way that maybe they would want to predict, you know, in this time of year for a 43-day window, we have like the last 20 years dating back of data. And you can use this to try to predict what the daily wind speeds will be for that month or, you know, that 43-day period based on a large data sample over many, many years, okay? So it says, what percentage of speeds was above 60 miles per hour or below 20 miles per hour? So let's see, above 60. Well, that would be these guys, right? So how many guys were above 60? So let's count. So if we look over here, that's a 4. And if we look over here, that's a 1. Okay. So we know this category right here from 60 to 70 had 4 and 1. So we're going to say 4 plus 1, which is 5. Now it says what percentage of speeds was above 60 miles per hour or below 20. So never mind, I made a mistake. So all we did is we found that there are 5 here. That's above 60, but we also need to find how many are below 20. Well, that would be this one and this one. So that would be 5 plus 2, which is equal to 7. So then if they want to know what percentage, we just do 7 divided by, how many days was it? 43 days. So there's 7 days that had below 20 miles per hour and above 60 miles per hour. So we're going to divide by 43, and we should get around 0.163. And then we're going to say that this is actually 16.3%. Remember, you can just change it to a percent by multiplying by 100. Okay, or 100%, I should say. So this will be 16.3%, and that would be our answer. Describe in detail the shape. Why does it keep doing that? Describe in detail the shape, center, find the median, interval, and spread of the distribution. So the shape. Okay, 2 aspects. Well, if I were to draw my little drawing like I've been doing, right, without the outlier, where does the tail look longer? The tail looks longer over here, right? So I'm going to say that this is probably left skewed. Okay, with, and let's name something, with an outlier at, what would that be? 0 to 4? Yeah, 0 to 4. Remember, it can't be 0 to 5 because then that means you're including 10 and 20 in both intervals, right? So it's from 0 to 4 miles per hour. Okay, so there's that. Now the center we could find by doing 43 days plus 1 and divided by 2. So we get 22. So now we need to go and count until we hit 22 days. So I'm going to start counting right now, right? So here's 1, here's 1, here's 1. So that's 3 total so far. Here's 2, here's 3, here's, what is that, 6. So do we get to 22 yet? 1, 2, 3, 5 plus 8 plus 6, 14, not quite. This would be 4. So that's 9, 10, 14, 18, still no. This one is 5. So now let's add this. 5 plus 4 is 9, plus 6 is 15, 21, 22, 23. So yeah, we hit 22 in this category right here. So that would be from 40 to 44. So class or median interval from, oh no, that's not from 40 to 44. That's 45 to 49. That's this one right here, right? So that would be 45 right there. Oops, that's not very nice. So right there, that would be 45, right? So that would be from 45 to 49. Remember, we can't say from 45 to 50 because that means the next class, which also starts at 50, would be including 50 in both classes. So you have to be careful of your numbering on this, and you might get a few wrong on your calculator or on your homework if you don't pay attention to that. So the spread, the smallest, that's not an outlier, is from 15 to 19 to 65 to 69. And all I did was I took, let's clean this up a little bit. all I did was I took this first category, 15 to 19, and I took this last category, 65 to 69. That's going to be my spread. And again, we know with an outlier, remember, you tell somebody this that's reading it, why are you not including 0 to 4? Because 0 to 4 is an outlier. Okay. So let me see how much we got left. So I think I'll do that in the next video. We can go over some of this in the next video. Okay, you guys, so that's going to do it for chapter 2 video part 1. I'll post this and then we'll do chapter 2 video part 2 a little bit later. Okay, so we'll leave off there. All right, you guys, thanks for watching, and I will see you in class.